Alright, we are going to chapter 8, last chapter of the year, and we are doing functions. A function is a relation that you put in a value and you get out a value. Sometimes the same value, sometimes it's different. But it's a special relationship where you put in one number and you get one number out. Okay? It's kind of like a machine. You put something in and it's going to transform it into a different number. So we'll take a look what that looks like in a second, but let's write down our vocab terms here. We have independent variable and dependent variable. Okay. The independent variable is independent. You get to really choose whatever you want it to be. It could be anything you want. The dependent variable is what you get once you choose your independent variable. So it depends on what you choose. So the independent variable is your domain, which is your x value. Okay, so make sure you write this down. The domain is x, and your range is your y value. So you get to choose your x usually, or they tell you your x, but what your y is depends on what your x was first. Okay, so I like to draw a little machine for these functions. Okay, so I'm going to put in a number into this little box. All right, and let's say it's going to be x minus 1. Okay, and I'm going to get out a new number. So if I put in, let's say, number 2 into this machine, it's going to say 2 minus 1, and it's going to put out 1. That's my output. So I put in 2, I get out 1. If I put in 4 minus 1, I output 3. So a function has a certain rule that it has to follow. Now, if something else happens, like let's say I put in 2, and the number is 1, and the number 3 came out. Well, my machine's clearly broken. It's giving me wrong answers. That would not be a function. So this chart over here is not a function because it's saying, hey, when you plugged in 2, what you got out was 1 and 3. Okay, so if there's two numbers that come from 1x, that's not a function. All right. Now these, we want it to be a function because we know it'll follow a certain rule. It's not broken. If it's broken, it doesn't really do us much good. Okay, so just from this page, keep in mind your independent variable is your x. Your dependent variable is your y. Okay? If it's a function, only one number is going to come out. Alright, so let's see if we can determine whether it's a function or not. So, again, these are all my x's. The first numbers are my x's. And my second number is my y. So they're saying when I plug in this number, this is what I got out. When I plugged in this number, this is what I got out. Okay, so was there any of these points that I plugged in a number and I got more than one answer? Well, I plugged in 54, I got 112. Ooh, I also plugged in 54 and then I got 123. That's not right. I should get the same number for both. So this is not a function because, well, 54 gave me two different numbers. Also, if you look here, 56 gave me two different numbers. So it's a really messed up function. Alright, so that is not a function because the same number gave me two different answers. Here, 4 gave me 6, 7 gave me 10, 6 gave me 11, 3 gave me 8. None of these are repeated. Okay. If it did repeat, let's say I plugged in 4 again, I should still get 6 out. Okay. So this is a function because I don't have any numbers that gave me two answers. Okay. All of these could give me the same answer, but I can't get more than one answer from 1x. So this one is a function. Alright, this is a function. Look at the guide. To practice quick, here I plug in 5, I got 1. Plug in 6, I got 3. Plug in 7, I got 5. Plug in 8, I got 0. No repeats, no two numbers from 1x. That one's a function. That one's good to go. This one, look at this. I plug in 1, I got 7. Later on, I plugged in 1 and I got 8. Not a function. Gave me two answers for the same number. Okay, not a function. Also, if they give you a graph, these are x and y points, all these, so they could be graphed. We do what's called the vertical line test, meaning if they put it on a graph and you scan the graph vertically like this, take a vertical line and they use a pencil, which is what you'll have. You scan the graph. If you ever hit 2 points at one time, it's not a function. So this graph that I'm scanning across right now, this is a function because I'm only going to hit 1 point. There's 1 point I hit. There's 1, there's 1, there's 1. I'm going to draw another point in here so you should see what not a function looks like. It's going to be like this right here. Okay? Because I scan it, right there I'm hitting 2 points at the same time. Okay, that's saying when I plugged in 1, 2, 3, 4, 5, x equals 5, they gave me 2 different answers, so it's not a function. So it's just a different way to check whether it's a function or not. Okay, so if I get rid of that point I drew in there, let me drag it. The original one, this is a function because it only hits 1 point at a time. So yes, it is a function. Function notation, this is how we, I'm going to go back there. That was called the vertical line test. Sorry, write that down quick. Vertical line test. Only hits 1 point at a time. It is a function. If it hits more than 1, it is not a function. Alright. Function notation. This will be new. Okay, so instead of writing, if I plug in x, I get a y, they can also write it like this. Okay, this is read as f of x, meaning the function of x. What is happening to x every time is basically what it's saying. In this case, it's saying, hey, you're going to multiply it by 2 and then add 3. That's the function. That's what the machine's going to do to whatever number you plug in. You're going to multiply it by 2 and add 3. These are the same problems. This is function notation. This is an equation over here. Alright, so when you see this is saying whatever you plug in for x, you're getting a y value out. Okay, it's really the same thing, just 2 different ways to write it. So let's see, this is the main thing we do with functions here. We test, or we see what values equal what. So here they're saying, this is said f of 5, or the function of 5, meaning what happens when you plug in 5 into your function, your machine. Okay, well here's what it's telling me my machine should do. I'm plugging in 5 into it. What number should come out? Well, I'm going to plug in 5. I'm going to do 4 times 5 minus 7. I'm plugging 5 right there. Okay. 4 times 5 is 20. 20 minus 7 is 13. Okay. There's the function of 5, or f of 5. This one tells me to do the function of negative 6. It says plug in negative 6 in your machine. Tell me what number comes out. Okay. So I'm going to plug in negative 6 wherever I see an x. Okay, so I'm going to plug in right there. 4 times negative 6 is negative 24. Subtract 7, negative 31. Okay, guided practice down here. Here's my function notation saying whatever x is, you're going to multiply by 3 and add 14. So if my number is 4, the same plug in 4, I'm going to do 14 plus 3 times 4. 3 times 4 is 12. 12 plus 14 is 26. So that's the number I get out. Okay, you can do that one also over there. Alright, last slide. Real world example. Mariah spent $22.50 downloading songs. Cost her 90 cents each. Let's write the function. Alright, so what can I change? Well, what I can change is the number of songs I can buy. So that's my independent variable. And you can buy 18 songs, you can buy 2 songs, you can buy no songs, you can buy 30 songs. That's my independent variable. So that's my x, number of songs I can buy. Okay. You could also put any letter you want. You could put the letter S if you want for songs. How much does it cost per song? Well, 90 cents. So however many songs you buy, S, you're going to multiply it by 0.9. Okay. And then we want it in function notation. So what is function notation? Well, you can put whatever letter you want. Usually put F. They're going to put C because they can make it represent cost. But I'm going to put F. The function of, and then you put your letter in here, S. Okay, so it's saying the number of songs, or the price you pay for the number of songs, is that number times 0.9. Okay, so here's what the function should look like. Right here, they use C, doesn't really matter what letter you use, but they're saying the cost is equal to 0.9 times the number of songs you buy. So you just write an equation. And then part B, they want you to find how many songs did Mariah download if she spent $22.50. Well, that means the total cost was $22.50. So I'm going to plug in $22.50 in for the cost. It's going to cost 90 cents per song. How would you solve this equation? That's right! You would divide both sides by 0.9, and you get S equals 25. She bought 25 songs if she spent $22.50. Alright? So there's lots of things we do with functions. The biggest thing we do is we evaluate them. We plug in a value, see what comes out. It's like a machine. You put something in, what comes out. And then here's your real world example. Alright, have a wonderful day. I will see you in class.